carbohydrate derivatives, soluble zinc salts, soluble borates, and some other salts. Menthol is also a possible retarder. So all these material, all these are retarders. Causing very small dosage of cell of the order of 0.05 to 0.1% of the mass of cement is enough. So retarder, very small dosage is enough. What happened? 0.05% sugar can delay initial setting time by about 4 hours. See, very small amount of sugar, you are adding 0.05%, it is delaying the initial setting time. Great care is necessary in using retarders. Please focus. Because inc- incorrect quantities, they can totally inhibit the setting. If you use high dosage of retarders, you will not able to set the concrete. So the total process will get disturbed. The entire concrete is will be spoiled, and therefore hardening of concrete will not take place. So you have to use correct dosage of this. Clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Okay. Now let us come to the next admixture, which is called air entraining admixture. What happened, Kautik? Hello? Hello?
Yes, sir.
Sir.
You're able to hear?
Yes, sir.
Yes, sir. Yes.
Okay, air entraining admixtures. Air entraining. What is this air entraining admixtures? Yes. Air entraining admixtures help to incorporate a controlled amount of air. Now, what I am doing here, I am introducing air into the concrete. Controlled amount of air is introduced into the concrete in the form of millions of. Hello? చెప్పండి దుర్గాప్రకాష్. అది చూస్తున్నానండి, క్లాస్ లో ఉన్నాను, అయినాక చూస్తాను నేను. ఇది ఒకటి పంపించినట్టున్నాం కదా, ఒక షెడ్ దీని చేశారా? నేను చూస్తాను ఒకసారి. దీని డ్రాయింగ్స్ ఇవ్వలేదు కదా, ఇచ్చారా? ఇది ఒకసారి చూస్తానండి, ఇపోది ఒకసారి చూస్తా, ఫస్ట్ చూడలేదు కదా మనం. ఇది షెడ్ది ఇస్తానండి, కొంచెం క్లాస్ అయిపోయినాక ఇస్తాను మీకు. నాన్ కోయల్సింగ్ బబుల్స్ distributed throughout the body of concrete during mixing without significantly altering the setting or the rate of hardening of concrete. Very important. Air entraining admixtures, I am allowing air into the concrete. I am introducing air into the concrete in the form of small bubbles. Now, why am I doing this? Now, this will not alter your setting time or rate of hardening of concrete. Nothing is going to change. Why then I am adding? A proper amount of entrained air results in improved properties of plastic concrete. Improved properties of plastic concrete. That means in fresh state, I want to introduce some of the properties. I want to enhance some of the properties. So what I have done here is, I have introduced air. This air will improve the workability of concrete. This air will improve the workability of concrete. Easier placing and finishing. Increased durability. Better resistance to frost action. And reduction in bleeding and segregation. Reduction in bleeding and segregation. Two important problems. Bleeding and segregation are two important problems. So now what I am trying to focus is, why am I adding these properties? Why am I adding this air entraining admixture? because this will improve my workability. Because there are a lot of bubbles introduced into the concrete. These bubbles will add as lubricant, add as lubricant between the cement particles and water molecules. Therefore, your workability will increase. Therefore, your workability will increase. Because workability has increased, it becomes very easy to place and finish the concrete. It becomes easier placing and finishing the concrete. Increased durability, because you will have compacted concrete, dense concrete with less voids. Therefore, since you have concrete with less voids, you will be able to have durability increased. Durability is nothing but the time required. Durability is nothing but what is the life of the concrete, that is increased. Better resistance to frost action, to that snow and wind load, water load, this we are able to resist. Bleeding and segregation, I already discussed. Bleeding is nothing but loss of water from the concrete. Segregation is nothing but separation of particles of the concrete. Different particles, they separate out differently. So that I am trying to avoid here. The air voids present in concrete are classified as, now very important, there are two types of air voids in the concrete, either as entrained air or entrapped air. Entrained air, entrapped air. We are now defining what is entrained air, what is entrapped air. Entrained air is intentionally incorporated, very important. I am purposefully incorporating air into the concrete, that is called entrained air, in the form of minute spherical bubbles as referred above. In the form of minute spherical bubbles, I am reintroducing air into the concrete. Entrapped air, entrapped means entrapped air is in the form of voids occurring in the concrete due to insufficient or poor compaction. Because compaction is not there or the poor compaction, what happens is the air will get entrapped. Entrapped air is different, entrained air is different. Entrained air, I am adding purposefully. Entrapped air, in the process of making concrete, some air is trapped inside the concrete, trapped inside the concrete. Typically, if you do compaction, the air should come out, but since your compaction is not proper, that air has not come out, it got entrapped in the concrete, and that is called entrapped air. Entrapped air voids may be of any shape and size, non-uniformly distributed along the contours of aggregate surfaces. That is the entrapped air. Their size is large and ranges from 0.01 to 1 millimeter or more. Entrapped air, the size of the air bubbles, the size of the voids is given there, 0.01 to 1 mm. They are sources of weakness in the concrete in terms of strength and durability. They are sources of weakness in the concrete. So that is problem. Wherever the air voids are there in the concrete, they are the sources of weakness. Air, they form a weak layer. Therefore, you will not able to get a dense concrete. Entrapped air means when air is trapped inside. Give me a minute. Hello, sir. ఆ ప్రాబ్లం మీరు వచ్చి చూడండి సార్ ఒకసారి 1 గంటకు రండి. అది మీరు చూడాలి, నాకు తెలియట్లేదు, అది రన్ చేయట్లేదు, ఏదో ఉంది ప్రాబ్లము. మీరు 1 o'clock వస్తారు కదా, అప్పుడు చూద్దాం. జల్వాయ్ విఆర్ 36 జల్వాయ్ విఆర్ 1 o'clock రండి, మేము ఆఫీస్లో ఉన్నాం ఇప్పుడు. Air entraining admixture, air entrainment will, while improving the durability and plasticity, may have adverse effect on the strength of the concrete. The decrease in strength is proportional to the amount of entrained air. The decrease in strength is proportional to the amount of entrained air. Very important. So, how much air is entrapped, we have to see. The effect of increase in the percentage of entrained air on the compressive strength is shown below. Now we will see a graph. Please see this graph. We have drawn a graph between compressive strength and entrained air. So if air percentage is suppose 10%, if your air entrained is 10%, the compressive strength is very low. If you come to this end, the air entrained is 0%, the compressive strength is 30 megapascals. You are able to understand the difference. All other things remain same. Sand proportions, water cement ratio, same thing. If the difference in entrained air, the amount of air if you are entraining, see the difference in the compressive strength. If it is 0%, your compressive strength is 30% MPa. If the air entrained is 10%, your almost your compressive strength is 16 or 17 Newton per mm square. Clear?
Yes, sir.
Okay, sir.
Okay. So now this is what we are saying. For each percentage increase in the air content, the compressive strength reduces by 1.4 MPa. Very important. For each increase in the air content, for each increase in air content, the compressive strength reduces by 1.4 megapascals. The more the air is entrained, the more the air in the concrete, more is the less is the compressive strength. More air, less compressive strength. Very simple. Next, factors affecting amount of air entrainment. What are the factors which affect air entrainment? Type and quantity of air entraining agent. What is the type of air entraining agent? What is the quantity? What is the percentage of air entraining agent you have used? Very important. That is why we should know the dosage of the admixtures which we are using. Okay. Yes.
Yes, sir.
Water cement ratio of the mix. Water cement ratio of the mix. Next, type, grading and maximum size of aggregate. Type, grading and maximum size of aggregate. Next, mixing time, temperature, type of cement, extent of compaction of concrete. All these factors will affect the amount of air entrainment. Amount of air entrainment. Different entraining agents produce different amounts of air entrainment. Very important. Different